Welcome back. So today on the agenda, make sure that you guys do the bell work check-in. That's I'm taking attendance. We're going to do notes on the tangent line, has some practice problems embedded, and then a Google form at the end. By the end of class today, you should be able to find the missing angles of a right triangle based on the tangent. Okay, so what we're going to be focusing on right now is right triangles. So whenever I'm referring to an angle on the triangle, that's going to be our reference angle, and a lot of the time I'm just going to call it theta. So this symbol right here is the Greek symbol for theta. So if this is 90 degrees, and then I'm going to go ahead and I want to solve for this angle theta. The nice thing is once you solve for theta, well, what do we know about triangles? They're 180 degrees. So if this angle is theta, this angle has to be 90 degrees minus theta, because in order to get the sum of 180, these two would have to equal 90, because this one equals 90. So once I solve for this angle, I can then solve for this angle by using the equation 90 minus theta. So in a right triangle, the tangent of an angle is the ratio of the side opposite the angle divided by the adjacent leg. So if we have our right triangle here, remember our 90-degree angle always points to the hypotenuse. I'm making my theta this angle here at the bottom, at the base. Because this is theta, in reference to theta, this side, besides the hypotenuse, it's also touching this base side, this leg. So I'm going to label that my adjacent leg. And then theta will point to the opposite side. So then this means that my height here in this case is opposite to theta. Now versus, notice if I make theta this angle here, since this is my reference angle theta, the only thing that doesn't change is my right angle still points to the hypotenuse. But now notice if I'm using this as my reference angle, my adjacent side is my height because my theta touches the adjacent side along with the hypotenuse. And then my opposite side would be the base. So that's just very important. Thinking about, depending upon which angle you label as theta is going to be then how you end up labeling your sides. And again, tangent of theta is opposite over adjacent. So the example here, find the tangent of S and the tangent of R in both ratio and decimal form. So I'm going to first go ahead and do tangent of S. So if this is my tangent S, that means my theta would be here, this angle. Okay. If I make that my angle theta, notice what angle or what side would be opposite to that and what side would be adjacent to that. So if my theta is here, that means adjacent is going to be the 18 and the opposite is going to be 80, because remember, right angle is points to the hypotenuse. So tangent S is opposite over adjacent, so it's going to be 80 over 18. And if you just type into your calculator 80 divided by 18, you're going to get 4.4444. Okay, and then for angle R, I'm going to make my theta here at angle R. And then notice with this one, since I'm making my theta here, now 80 becomes my adjacent, and then 18 becomes my opposite. So here it would be 18 over 80, which is, once you divide in your calculator, 0.225. So now, though, I want to actually calculate the degree of each of my angles. So I'm going to have that same triangle again, but now I want to know actually how much degrees is this angle here, angle S. So in order to do that, what I'm going to do is I'm going to set up my equation just like I had done in the previous slide, where I'm going to show the tangent of this angle is opposite over adjacent. So I have tangent of S is equal to 80 over 18. Now what I want to do, because I want to isolate S, or my theta, and figure out what it is, that means I have to eliminate tangent. So in this case, remember how we always do the inverse operation in order to isolate? So the inverse operation now is considered tangent to the -1. So this is inverse tangent. So in your calculator, you would end up typing the second key and then tangent, and that's going to change it to tangent -1. And then you would type in your fraction, 80 divided by 18. And once you do that, you get 77.32. Go ahead and try tangent of R, because you know what it should turn out to be, even to check your work. If you know that this angle is 77.32, you can just do 90 minus that to get this angle, so you can check your work that way. And you should get 12.68. Now find the tangent of K and tangent J in both ratio form and decimal form. So go ahead and do the exact same thing that we just did on the last example.